Okay, so in the previous video I took quite a while to derive somewhat this form, okay, but actually I didn't derive everything. But I just want to say that this thing over here is your transformation matrix. Alright, you transform your sigma x and sigma y into sigma 1 and sigma 2. Alright, this is your sigma x and your y, and you translate with a certain angle to a 1 and a 2 direction. These are the theta, the angle theta. Okay, you apply your theta, your transformation angle, into all this, and eventually you can transform your x and y stresses into your 1 and 2 stresses. Alright, so the purpose is to calculate the laminate, because your laminate in this shape. Okay, but however your fiber is being arranged in a certain angle, so you want to actually know what is the stresses being acted onto this laminate, this fiber, alright, and things like that. And why do we want to analyze the stresses then? Because it is needed. I also don't know why. Okay, anyway, so this is the same equation, alright. Over here, what I just said is the same thing all over here. Okay, so what they are trying to say is that this thing over here in this page is this thing over here is your transformation matrix. That's all it is. Okay, and the angle theta is the angle from the x to the 1 axis. Alright, so this is the x, this is the y, the 1 and the 2, so this is the theta, and this is why he's trying to say, please take note of that. Okay, so please take note that this angle is over here. That's all it is. Alright, and then if you were to come to here, trying to say is that if you were to convert, alright, back from your sigma 1 and sigma 2, previously we convert from x to the 1 direction, right? We are moving in this direction. Now we're actually moving back, alright, from 1 to the x direction. So therefore it's an inverse transformation, as you can see. So the inverse transformation requires another equation. Alright, so the transformation inverse is actually this one. Alright, so it's kind of different from this page over here. Okay, the differences are the plus minus sign. Alright, plus minus v sign. Over here this is minus, this is for your inverse. Alright, over here this is a plus. Alright, so these are the little stuff that you may want to actually check it out lah. But I will not go into details. But a direct comparison lah. Okay, as you can see, this whole thing is your T, your transformation matrix. This is your inverse of your transformation. Okay, as you can see, it's really different. This is sigma x, sigma y, this is sigma 1, sigma 2. Okay, so over here is exactly the same, nothing changed, only this portion changes. Okay, sorry, I should say that over here, okay, that nothing changed. Okay, nothing changed, everything is the same. Alright, the only changes is this two. Alright, so if this plus, you change to minus. If it's minus, you change to plus. Same thing, and that's all it is. Okay, hopefully it's pretty clear. Repeat again, this whole thing is the transformation matrix. This whole thing is an inverse of the transformation matrix. Okay, so once we come over here, I don't remember recording. Okay, I'm recording. Anyway, so this website is unable to log in. Alright, so I can't show you anything. I also don't know how important it is, but let's continue. Alright, and what it is saying in this page now is that instead of a stresses, we are talking about in terms of a strain. So over here, these are for your stresses. Alright, over here, these are for your strain. Okay, so this is your transformation matrix we have seen. This is your inverse transformation matrix we have seen. And over here, this is the transformation matrix of the strain. Alright, from the x and y to the 1 and 2 direction. Okay, so you also have a transformation matrix for your strain. Same thing, this is the inverse of it. Okay, while everything is the same. Alright, if you take a look on this transformation matrix and this, are there any difference? Exactly the same. Okay, the only differences is only this one, 0.5 gamma 1 2 and 0.5 gamma xy. I don't know why it is 0.5, but you just need to take note that there is a 0.5 over here. The rest are the same. Alright, your your stresses are the same, your strains are the same, just that the shear strains are 0.5. That's all it is. Okay, same thing all over here. This thing over here, this transformation and these transformations are the same. Okay, nothing changed. Okay, and this is what this page is trying to say lah. Okay, and therefore, alright, step B. Alright, this is actually a summary. Okay, sure, yeah. So this step B, I would believe, comes from here. Alright, where you know that your strain and your stress uses the same transformation matrix. I repeat again, your strain and your stress uses the same transformation matrix in terms of a transformation or a inverse transformation, as we have proved over here just now. Alright, so the step B is that. Alright, step A, I would believe, is just talking about the rotation, which we have said in the, or in other words, is this one. Sorry, it's not this one, it's this one. Okay, this is the step A, and as it said, it's the step A. So if you want to translate, alright, a certain stress from one direction to another, alright, you use this transformation matrix or the inverse. Then step 2, if you want to change to the strain, you can use the same transformation matrix to apply for the strain. Alright, and this is what it's trying to say over here. Alright, for your stress, alright, from xy direction, you can change to your 1-2 direction. Alternatively, you can change your 1-2 direction back to xy using the inverse. Same thing for your strain, and the transformation matrix is this one. Okay, and so in case you blur, alright, is that this thing over here is what we have been saying all along, and you should understand how to use it. For the stress and the strain, the transformation and the inverse transformation matrix are the same. Alright, except for the gamma, alright, your stress strain is 0.5. That's all. Okay, so we are all along from the start of the video to now is talking about this thing. It's very important. Alright, and if you want to change to a certain angle, you use the theta. Alright, the theta is just, this is the one direction, sorry, this is the x and y, this is your 1 and 2. Alright, the angle is here, and that's all. Alright, because I don't want to confuse you in the next part. Alright, so now we are coming into the next part. So this thing over here is what we have said just now. Okay, this is the inverse. So you translate the sigma 1 and sigma 2 back to xy direction. Alright, but however, you know that your sigma 1 and sigma 2 is actually this thing. And this thing comes from where? This thing comes from the previous videos we talked about. Alright, your stiffness matrix. All along, if you were to head back over here, alright, this is the one. Okay, it's called the reduced stiffness matrix in terms of Q. Alright, and the Q are all these informations given. Your Young modulus, your Poisson ratio. You need to know how to find. And in order to know how to find your Poisson ratio, you need to head back to your Poisson ratio page. Alright, lecture note part 1, page 56. This is how you find your Poisson ratio, although it's a mess, but at least you get the feel of the equations where it comes from. Alright, so likewise for your shear modulus, alright, please take note that, alright, this is for the thin laminate. If your laminate is a unidirectional or it is a anisotropic laminar, alright, you need to know that your shear modulus are all these things. They should be equals the same, 1, 3 and 1, 2 are the same, and things like that. You should be able to know that. Okay, if it's a isotropic material, alright, directions, all forces is the same in all directions, alright, then you're going to use this type of shear modulus. Okay, so these are the things that you need to take note along the way if you want to understand the full system. Okay, so therefore I'll sub in this thing, this sigma 1 with this, alright, and therefore it's over here, as you can see. Okay, and then this thing over here is being so-called summarized into this form. So your Q matrix is in terms of here, and your Q, if you still remember, is your stiffness matrix. Alright, and is equals to Q times this thing. Alright, because your strain is in this ratio. Alright, your shear strain is equals to 2 times your shear your your shear strain is 2 times of your strain in the third direction. Okay, so you just need to take note of that. Okay, so this is the form that you need to understand. Okay, so you need to take note of this form. Okay, I'm gonna make it very thick. Alright, you need to take note of this equation. Alright, where your transformation matrix we have known, alright, and your Q is this thing, and that's your Q is this thing, and where your Q, if you were to head back all along up to somewhere else, all these equations. Alright, so as you can see, it's a very huge chunk of things, but you just need to know this very simple thing in order to find your stress in the XY direction. Alright, and the purpose is y. Okay, this is your XY, this is your 1, 2 direction. Okay, and it is simple, always simple if you were to translate into the X and Y direction. Alright, if you were to translate back the 1, 2 direction, okay, in other words, it is always sorry it is always good if you were to translate the 1, 2 plane into the global plane, alright, which is the XY direction, for the simple calculation. Because let's say your laminate is in this direction, this is only for this template. However, you got another directions that maybe is in this direction, or maybe is in this direction. Alright, so in a general form, it will be advisable if you were to change your fiber direction into the local one. Alright, and this is why the focus is often on the inverse transformation matrix. Alright, and yeah lor. And therefore, what's now is that you have a XY stresses, okay, but however your strain is in the 1, 2 direction. Okay, so what you're gonna do next is to also transform your 1, 2 direction. Alright, so all this strain in the 1, 2, 3 direction, we're gonna transform into this, and this is why this whole thing over here is actually this one. Okay, it's the transformation matrix which we have shown you just now over here. Okay, so the XY you can transform into, or inverse transform into this thing. So your 1, 2 is inverse transform into this XY. And yeah lor, my fault, sorry. Your E1, alright, is equals to transformation of your XY. Okay, and this is why you gotta sub in your E1, your epsilon 1 and 2, in terms of a transformation XY, because you transform your epsilon X and Y into this thing, so you're just simply resubbing back. Okay, hopefully this is clear. Alright, because if you think about it, currently this is the thing, and what makes this thing is this one. So I'm simply subbing a transformation matrix times sigma X and Y into here, which is what we have shown. Okay, so hopefully this is pretty clear. And then and therefore this thing over here, this big chunk is here. Okay, if you think about it, you just compare, take a little time to compare. Alright, you just take a time, they are the same, tiobo. And this thing over here, they call this the Q bar. Alright, the transform compliance tensor. Alright, previously was just a compliance tensor. A compliance tensor is just a Q, that's all. Alright, a transform requires you with a bar. Okay, and therefore this bars, this equations, these Q's are in terms of all this thing. Okay, and they actually save you the hassle to go into the details. So your Q11, your Q12, all of them, alright, are these equations. I believe is provided to you for free. Okay, so this is the end in mind of everything. Okay, which is the step C, your last step. Okay, which is, if you come back all the way to here, where am I? Shit. Yeah, your step C. Okay, so the step A is to transform your stresses into a certain transformation. Alright, and then the step B is to know that the transformation matrix can be applied to the strain also. The transformation matrix are exactly the same. Alright, then we combine both steps and rearrange, you get a transform stiffness matrix Q bar. Alright, and this is why we have this on this page 44. Okay, so in other words, this page over here, alright, this thing over here is exactly the same as this one. Okay, while your Q bar is actually this chunk of information. Okay, this chunk of information all over here. Hopefully this is pretty clear. So this thing over here, sigma x and sigma y, is over here. Your strain epsilon, then your sigma x and y is here. Yeah. You give me a your sigma x and sigma y is over here. Okay, where your Q bar is equals to this thing, and your this thing is equals to this thing. That's all it is. This page is trying to say. So there is a lot of thing going on, but once you know it, it's pretty straightforward already. And this is the last page of that particular lecture. Alright. Given a certain strain, you are able to actually solve for the stress being applied. Alright. So normally if you were to measure the strain, alright, you should know the amount of stress or the amount of load taken by the certain fiber. Alright, then you will come out this, because this is the certain laminate. So this laminate, the properties, the certain stress of the properties that it can take will be set in MPa. Alright, so anything larger than this particular MPa will actually break your material. Alright, so you'll slowly measure until a certain strain where it breaks. You know that the laminate will break at a certain stress, and this is the stress amount for the laminate. Hopefully this is clear. So in order to let your customer knows how much stress your laminate can tahan, you first need to bring your laminate to experiment where you calculate the strain. Alright, you slowly pull until a certain place where the composite cannot take it, it breaks. You take in the strain, the amount of strain it has in all this direction, and then alright, you'll get the stress, and then you use this transformation matrix to get your stresses, and these are the stresses that will be taken into account when you sell your laminate, how much stress is able to take before it breaks. And hopefully this is pretty clear. And along the way, if you don't understand anything, I'll just suggest you click back the video and rewatch. Alright, once you rewatch, it should be quite straightforward already. And therefore, I'll leave you to it, and yeah.